My name is Jim Abraham, and I'd like to welcome you to this forum, Coping with Extreme Weather. I understand there's over 200 people registered for this seminar. There's people still joining us. And by the time we get to the first speaker, I hope everybody's online. I'm a meteorologist. I've been a meteorologist for over 40 years, and I'm located in Halifax. And I've spent my career studying and predicting extreme weather. I was involved with starting the Canadian Hurricane Center and the forecast and research program on hurricanes for Canada. And currently I'm providing advice to the media and on social media with coping with extreme weather. And certainly this year, like many other years, with the California wildfires and the historic hurricane season, extreme weather is in the news every day. And certainly our thoughts should be with those folks recovering from Hurricane Delta as it passed over the Yucatan Peninsula, and certainly the folks who are preparing for the arrival of another hurricane along the Gulf Coast. So certainly been a historic hurricane season. COVID-19 has resulted in many of us working remotely, and our electronic world is now providing us with opportunities and new things. And today is really an opportunity for the Canadian Meteorological and Oceanographic Society to offer this session across the country and to the public. This idea was initiated by Drs. Len Berry and Gord McBain, and is sponsored by the CMOS Ottawa, Canadian Club of Rome, and the Institute of Catastrophic Loss Reduction. We have 2 hours dedicated with 4 speakers sharing their perspectives over the first hour, and then you folks will be participating and given a chance to interact with the panel for the second hour. At any time, I invite you to share any questions or discussion points that you'd like to raise on the chat option on the bottom of your screen. And I will direct those to the panel members during the second half of the forum. Note that the presentations will be recorded, and that link will be shared with all of you afterwards. As well, we intend to provide you with a short survey so we can determine the value of this type of session and any other topics that you may like covered in the future. So the context for today's topic on coping with extreme weather is marking the 2nd anniversary of the Ottawa Gatineau tornado outbreak in late September of 2018, so just over 2 years ago. We have 4 panelists, as I mentioned. The first one will be Gord McBain. He's going to talk about the global perspective. He's with the Institute of Catastrophic Loss Reduction, and as well, he's the chair of integrated research on disaster risk management, and he's in London, Ontario today. Peter Kimball, he's going to be speaking on preparedness and response. He is the warning preparedness meteorologist in Ottawa with Environment and Climate Change Canada. Our third speaker will be Dave Sills. He'll be speaking on tornado risk specifically, and he's the executive director of a new organization, the Northern Tornadoes Project at the University of Western Ontario. He's also in London. And finally, Jen Spinney. Jen's going to talk about societal response. She's a professor of disaster and emergency management at York University in Toronto. I just remind folks to mute your lines. And once again, don't forget to share any thoughts you have via this chat option. So I'm going to now turn it over to Gordon. So while Gordon's raising his buttons and getting his screen on, one of the things I think Gordon is going to emphasize is the fact that populations are continuing to rise, and we're living in more vulnerable areas, and there's societal impacts as a result of that. So I think Gordon is ready. Make sure to unmute yourself, and I'll turn it over to you.
Thank you, Jim. Thanks, everyone. Hopefully everyone can hear me. If I see at least one thumbs up, or at least a smile. I can see Jen smiling in the thumb now, so that's good. So what I'm going to do, as Jim said, talk about a more global perspective of involving societal risks from severe weather events. I've been working on this for a long time. I'm the only guy in this, probably on the call, who was actually a weather forecaster in the 60s when we had not a single computer in our office in Toronto at the then Moulton Airport. Anyway, I want to give a broader perspective just as an opener to say that, what's going on? Yes, we are right now in COVID-19 pandemic. It's been affecting all of us in various ways. Unfortunately, over 1 million people have died around the world, and there are 36 million cases in round numbers. The big question is, where are we going? When will we have a vaccine? The projections are from 2 to 4 million people who will perhaps die as a result of this. So I think one of the things we can do is learn from the response from the COVID pandemic and see how we can address these issues, so that we address the issues of climate change and environmental issues in our recovery from COVID more effectively and bring these things together. And one of the things that strikes me when we look around the world to see how various countries address COVID, we can look at the case of the situation in Taipei, Taiwan. I actually gave a seminar by Zoom in Taipei about 2 weeks ago. They have a population of not much smaller than Canada, and the net effect was their action resulted in only 7 deaths. They brought in quickly testing. They did track tracing of everyone to see where the cases were, contact tracing, and quarantined those who'd been affected. This was led by Dr. Chen, the vice president of Taiwan at that time, who was interestingly is a epidemiologist, a scientist, a former vice president of Academia Sinica, and actually a person that I have met over the years. Here I discovered back in 2007 at the International Conference on Urban Disaster Reduction. If you can recognize the old faces, there's the guy with the less hair than he has now, and he claims anyway, and Dr. Chen, who was then the minister. And I guess the point I'm making is that as we connect across the hazards, we can learn how to address them more effectively. So we were talking there about urban disaster reduction. So let's look at a global perspective. This is the World Economic Forum, which everyone uses as a place to discuss things, politicians go, etc. And they put out what's called a global risk report every year. They put it out in January. Interestingly, this year, the Global Risk Report 2020, which went out in January, actually didn't talk about COVID because it wasn't really yet on their radar screen. But let's talk about what they do. They do a global assessment of things that will happen in the next 10 years and have big impact. They look at impact and the likelihood of these things. Up in the corner with the big impact is weapons of mass destruction, basically nuclear war, also infectious diseases, which they felt was unlikely at that point. But then if you look up in the corner where the ones are of most impact and most likely, climate action failure of governments to take action on climate change adaptation and emission reductions, and extreme weather events, issues of natural disasters, human-made environmental disasters, biodiversity loss, water crises. Now, all of these things link together with basically our environmental situation. And I think it's very important that we deal with these things. We also need to make sure we understand the connections between them. Climate action failure is leading to more extreme weather events. They in turn impact biodiversity loss. They affect water crises through droughts and floods. And we know we need to learn back and forth with the issues of infectious diseases. So I think what I want to stress is a statement made by the Secretary General of the United Nations, who said, if I had to select one sentence to describe the state of the world, I would say we are in a world in which global challenges are more and more integrated and the responses are more and more fragmented. And if this is not reversed, it's a recipe for disaster. Secretary General. And so what we need is an integrated approach to addressing hazards, including COVID-19, and have an integrated, strategic, scientific-based actions to reduce the risks and impacts. If we look around the world, and these numbers are just one source, but the number of disasters, hazards is not something we have detailed numbers on totally, but the overall impact, if we look at them, of floods, which are the biggest numbers, storms, also a big number, heat and wildfires, drought, and geophysical events. The particularly floods and storms are increasing in numbers quite dramatically. And in the opinion of most of the scientific community, this is related to a change in climate, and we can project this to happen further as we go ahead. So let's look at some of the recent events for illustrative purposes in the Canadian scene. We have the 2016 Fort McMurray fires, huge impact on the regional community of Wood Buffalo, destroying thousands of homes and other things. And the point is, though, many of the issues, but as the Premier of Alberta said in June 1st, when they were returning to the first residents were beginning to return, there is still a lot of work to recover and rebuild Wood Buffalo. This will be the work of years, not weeks. The point of this is that these are huge events which have long lasting. They're not just wham in and wham and over. And the point also, unfortunately, is that the projections are, in looking at wildfires, that we will see with the changing climate, probably a more than 50% increase in the occurrence of wildfires in those areas on the map. The Eastern Canada ice storm back in 1998, when I was the Assistant Deputy Minister for the Weather Service, had huge impact on Quebec, Ontario, New Brunswick. There was millions of people, or a million people without power across this thing, and this huge impact. It had great impact on us economically, but I just wanted to stress the social and health dimensions. According to the scientists at McGill University who studied children who were in their mother's womb at the time of the stress event that their mothers went through, those children whose mothers experienced high stress during the ice storm scored lower on IQ and language performance tests than those whose mothers had less stress. And although with warming, we will have a shorter period of freezing rain, the increased probability of freezing rain events of more than 4 to 6 hours will probably go up by 40% by 2050. More recently, the Alberta floods, 100,000 plus people, 3 people killed. And again, people stressed of this, and with the changing climate, we project that by 2050, we'll have twice as many heavy precipitation events and more floods. Now, just talking about some others, just to put in context, the terrible Pine Lake tornado in the year 2000, which tore through the Green Acres campground in Pine Lake, killing 12 people, injuring over more than 100 others, and devastating this whole community. I visited the site not long after the event and was tragically told about one young child who was killed as her mother ran desperately trying to find a place of safety, but there were not any safe places to go, and the child was swept away by the tornado. We'll talk today about the Ottawa area tornado of 2018. We also had, since then, the Ottawa River floods in 2019, which actually was record-setting and exceeding the 2017 flood, which had then also had already been considered the flood of the century. Here was many things, and unfortunately, 2 lives lost, one in Ontario and one in Quebec, and the impact of this was well beyond the Ottawa area. Most recently, we've had in June 2020, the Calgary hailstorm, no deaths, but $1.2 billion in damages to homes and property, vehicles, and others due to this hailstorm. So we are looking now is realizing that we're just finishing, or the data is now coming out, that the warmest decade in Canada's history was 2010 to 2019, 1.42 degrees Celsius warmer than the long-term conditions since 1948. I think it's important when we talk about 1.5 and 2 degrees C globally to recognize that Canada is warming about twice as fast as the globe. And with that warming will be a higher risk of extreme events, storms, floods, droughts, etc. So one of the things that's I just wanted to flag, and Jen will probably talk about indirectly this in, here we have a tornado coming across. This was a pictures taken. And there we have a guy mowing his lawn. and this went into the media. And I asked the question, why didn't he get out of the way? And he said, well, we didn't need to worry about it. He knew it was coming and he could go. But the question we need to ask is, how do people respond to severe weather events? Do they hear the warnings? What do they do? What are the right actions to take? And how can we work on what we call risk interpretation to action, which is one of the research areas of integrated research on disaster risk global program. So just looking at this generally, I wanted to stress when we talk about risk, context of hazards, exposure, and vulnerability, we need to recognize that there isn't things as natural disasters anymore. There are natural hazards, earthquakes, volcanoes, etc. But it's because we make our choices of where we habitate, where we build, what research we do. And the risk is a combination of the hazard, the exposure, the vulnerability, and the death and loss that results from that exposure vulnerability. And we need to make more informed choices about how to reduce our exposure and vulnerability so we have less impacts of the natural hazards. One of the areas of concern is health. And this just is to say, we have within Health Canada, the Health Adapt program from Health Canada, working on the issues of health systems, health of Canadians, and how can we take actions to carry out more climate change health adaptation plans with partners in the community. Very quickly, the Paris Agreement talks about emission reductions. That's very important, mitigation. It's also very important that we have adaptation strategies, including early warning systems, better ways of forecasting, predicting, and taking action. There's also one which most people unfortunately haven't heard much about, called the Sendai Framework for Action on Disaster Risk Reduction, which has among its many targets having more early warning systems, better enhancement, more risk information, and that's the kind of things we need to be addressing. Also, the Sustainable Development Goals, and there are 17 goals as part of this, of building resilient infrastructure is number 9, and cities, human settlements to become more safe and resilient. And I think today, those are the issues we're talking about: warning systems, resilient infrastructure, cities that being safe and resilient. And these three together are what I call the global agenda, and most people call Global Agenda 2030, and Canada is a signatory to all three of these. So just to say,
3 minutes, Gordon.
The issue, we've got all of these together, of these research programs, including the one on disaster risk reduction over here, of which ICLR is the International Center of Excellence on Disaster Resilient Homes, Buildings, and Public Infrastructure. And we need to have integrated science, integrated roles, including national roles of Canada, feeding into this global approach. As I say, we need to build on science for our children and grandchildren. Here's my daughter, her husband, and 3 of my grandkids sitting on Einstein's statue, symbolically building on science for the benefit of our children and grandchildren. And we have a tsunami coming. And I think it's time to go beyond standing in front of the tsunami and reading a declaration. We need to have action. So with that, I thank you for your attention. Now let's move ahead together. Thank you very much.
Thank you very much, Gordon. Our next speaker will be Peter Kimball, talking about preparedness and response. When Gordon was talking, I was really reflecting on this integrated challenge. I mean, we're in a system right now where we've got really pandemic on our mind. It's certainly extreme impact in the globe, and certainly in a number of our provinces. But at the same time, as Gordon pointed out, we're still at very high risk from climate change and from extreme weather. And you think of the folks in the Gulf Coast, and certainly some of the pictures I saw yesterday from the Yucatan Peninsula, the challenge emergency managers have to evacuate people and put them in shelters, but at the same time, we're expected to social distance. And certainly that is a challenge, and it continues to be a challenge with respect to severe weather and this integrated challenge that we're dealing with. So I see Peter is ready, and I'll now turn it over to you.
Well, I hope you can hear me, Jim, yes?
Yes.
Great. Okay, so I have, I'm starting my stopwatch here for my own purposes. I have 22 slides to talk about in 12 minutes, so I have to talk really fast. So please bear with me. I'm going to talk about the Ottawa Gatineau tornadoes of September 21st, 2 years ago. So this seminar basically is basically motivated by the fact that it's the second anniversary, roughly, of that particular event. So an overview of the contents of what I'm going to talk about. I'm going to talk about an overview of the event. Environment Canada and tornado warnings, warning on radar, alert ready, wireless alerts, tornado climatology, and emergency preparedness. In a nutshell, that's what's coming your way as I speak. So the first slide, September 21st, 2018, there were actually 7 tornadoes on that day. 3 of them over Quebec, 3 of them over Ontario, and 1 of them basically that straddled both provinces. The 2 most significant ones were the Kenburn, Dunrobin, Gatineau EF3 on the enhanced Fujita scale, and then the Ottawa Nepean EF2. I say significant because of the number of people that were impacted. No fatalities, 6 injuries in Ontario, 17 injuries in Quebec, $344 million of damage, 189 kilometers of damage path, which is not a record, but it came close to the record, which was from the 2009 Toronto, the GTA event, essentially, at 157. Sorry, the 1985 Barrie outbreak exceeded it. So nevertheless, it came close to a record for the total damage path that the tornadoes took. Here's a slide showing you the trajectory of both of the most significant events. One of them, basically the northern one began over Kenburn, went over Dunrobin at an EF3 strength, and then Gatineau EF3 before it petered out. The second one, an hour later, began at 5:50 p.m. Over Bell's Corners, reached its peak basically over Arlington Woods, and then petered out over just as it approached the 417 after Greenboro. Here are a few photographs that show you some of the damage from that particular event. This is from Dunrobin, looking to the east of the Gatineau Hills, off in the background. The worst damaged houses were basically right along the path from the southwest on the lower left portion of the photograph to the top right. You can see a couple of houses completely demolished there. There was the one house, the house on the bottom left on the first picture is the house that's demolished in front of you here. I think that the fellow who, the owner of the house is probably listening to this call. I think that's what he was planning to do this morning. He was actually in PEI on holiday, and when he heard the news that his house has been destroyed, he came back to this particular kind of destruction. Interestingly enough, he had video cameras mounted on his house, which actually captured some of the winds increasing as the tornado approached. And then, of course, as the house blew apart, the video footage died away. And on the right, you'll see an outbuilding, which was his observatory, which survived intact because it was mounted on helical piles, so it was extremely well anchored, essentially, to the ground. Gatineau suffered a lot of damage as well to low-rise apartment buildings. And here you can see also a car that was overturned. And there was a lot of projectile damage as well, as is typical in tornadoes. You see here a 2x4 through a windshield of a car. The Ottawa Storm basically started, as I said, in Bell's Corners, and then caused a lot of damage here in the Bruce Pit area just west of Arlington Woods. Arlington Woods suffered a lot of damage, as people know, because of the 150-foot pines that were snapped in half. That probably prevented a lot worse damage to the houses. And then it moved over Woodruff Avenue, where it toppled some hydro poles. And here's another picture of the damage in Arlington Woods. Studies have shown that a lot of Canadians don't understand the difference between watches and warnings. So with that in mind, a watch, a severe thunderstorm or tornado watch, means that there is potential for severe thunderstorms or tornadoes. Be alert. A warning means that severe thunderstorms or tornadoes are going to occur or are occurring. Take action. With that in mind, here's a slide showing you the timeline for that particular, on the tornado day of September 21st. In yellow at the top, the tornado watch was issued at 2:22 p.m., 2 to 2.5 hours before, lower left, In yellow, 4:49, 4:55, and 5:50 when the tornadoes actually hit Dunrobin, Gatineau, and Ottawa. So 2 to 2.5 hour lead time, which is pretty good. So that's my first key message. Environment Canada has improved a lot in terms of recognizing for and warning for high impact weather well ahead of time. My next key message basically has to do with the radar imagery. Here you see on the left a classic radar shot of a mesocyclone thunderstorm, sorry, of a supercellular thunderstorm in Alabama, with a classic hook echo on the lower left, and the corresponding radar image from Franktown radar, 4:50 p.m. on the 21st of September, with the same kind of hook echo. So we've learned a lot over the years, and I'm not showing you here the Doppler imagery of the velocity imagery, but essentially the forecasters are now no longer, as was the case probably many years ago, waiting for confirmation of something on the ground. We issue warnings based on radar imagery now. Our second speaker probably is one of the people who has been key in helping us along that path in terms of how we do that. So we warned based on radar, and here's what happened. The warning went out in yellow, in orange at 4:44 p.m. for Kenburn, Dunrobin, and Ottawa. And the tornado slammed into Dunrobin at 4:49, 5 minutes lead time, 4:55 in Gatineau, 10-15 minutes lead time, and an hour later in Ottawa with no warning. Now, I say that because I put a little asterisk there, because what actually happened was the first storm, the storm that passed across Kenburn, Dunrobin, and Ottawa, we warned for, including Ottawa. So the good news is the people in Ottawa actually did get that warning and were warned well in advance of the storm. But that actual tornado warning was ended at 5:35 approximately. And we did not have a tornado warning for the second storm further south. So unfortunately, that technically, although most people were warned, quote unquote, we didn't actually have a warning for that storm. That's why the asterisk is there. But the message nevertheless is warning on radar works for the clear-cut cases. However, many smaller events are not detectable by radar. There will be false alarms, and new upgraded radars will help. For example, in the Ottawa area, we have Franktown radar to the south. I think that Franktown radar will be upgraded next year, 2021. Not certain, but I believe that's the timeline. Anyway, the message is warning for tornadoes remains a challenging endeavor, but we are improving constantly. My next subject basically is wireless alerting. Many people, as we all know, got, well, we all know when we get an Amber Alert on our cell phones. Environment Canada contributes to the warnings, the weather warnings portion that comes on our cell phones. Tornado warnings only, and that's for within a 15-minute span of when the original alert is issued. So if folks had a cell phone turned on, it was a compatible device with the latest software, and it was connected to the cellular network, they should have received this warning at 4:44 p.m. on the 21st of September, which would have given them time to take shelter in their basement and to protect themselves. So that's my third message, is that wireless alerts do work. This program actually came into effect but only about 5 months before September 21st. It was in April that program actually began. So it was a success that people did get this message, or many people got the message and had time. Every minute counts. 1 minute is enough to take shelter inside or in a basement or in an interior room to protect themselves and their families. Next brief subject to talk about is the tornado climatology. I'm touching briefly on a subject that Dave Sills is going to talk about in the next presentation. The questions here to be asked are we seeing them more often, and have they ever happened in Eastern Ontario before? Well, have they ever happened in Eastern Ontario before? The answer is absolutely yes. Here's a map showing you geographic dispersion of where tornadoes have happened in our historical database. They certainly have happened in Ontario before. Even EF3s and above, Chesterfield in 1902, Brockton in 1903, Masson-Angers in 1978, Aylmer in 1994. Unfortunately, the ones that we just experienced a couple of years ago hit a very populated area, which is why they were so particularly destructive. but they certainly have hit Eastern Ontario before. And in terms of whether we're seeing more of them than we have in the past, a good question. Here's our database, but it suffers a lot of problems because, for one thing, look at the 2 zeros in 1957 and 1930, 37 and 55. Does anybody really believe that there were no tornadoes in the whole province in those years? I don't. The problem is that the early days of the database was, for the most part, information gathered by newspaper clippings. Since then, as Gordon mentioned in the 1960s in the weather office with no computers, well, now we have, in the 60s, we introduced radar networks, and then we had an F scale from classifying tornadoes, then we had downbursts, then we had tornado warnings, then we had storm spotter programs, then we had the weather network, then we had internet, email, cell phones, upgraded Doppler radar networks, tornado chasers, a big source of our information today, lightning networks, social media, Facebook, Twitter, smartphones, EF scale as opposed to F scale of tornadoes, alert ready program, wireless alerts, as I've already just shown you, a new upgraded radar network as is being rolled out right now, planet.com satellite imagery. Dave will talk about that. Drones, we have so many technologies now at our disposal. So of course the numbers are higher because we know when they're happening much more than we did in the past. So are they really increasing? I think the answer is we don't really know. A couple of other things to note is look at EF2 to EF5 tornado days. The number of days in Ontario when we had EF2, 3, 4, or 5s in Ontario, it's flat. In the last 50 years, it's flat at 0, 1, 2, or 3. So not clear. And in terms of the lightning trend across the province in the last 20 years or so, it's actually been going down. So it's not clear at all whether we're getting more tornadoes. Possibly we're not. Here's across Canada, lightning trend in the last 20 years, also slightly down as well. So the message number 4 is increasing remote sensing and communication technology is helping us become more aware of the true tornado climatology. More research is required, which leads into today's presentation next. And my last point, Hydro Ottawa Merivale substation, there was damage, as we all know, to the substation on that fateful September 21st. We had 170,000 customers without power. Hydro Ottawa had 170,000 customers without power, some up to a week. The Ottawa Emergency Ops Center was activated for 25 days. Here's some more damage from the substation. The issue, of course, is that emergency managers need to plan for rare, statistically improbable, but nevertheless possible, multiple simultaneous emergencies. Multiple tornadoes in an urban community, power outages. There were cell phone communication problems as well. So kind of like Fujita, kind of like the not the Fujita, kind of like the Fukushima emergencies in 2011, I think it was, where you had an earthquake and then a tsunami and then a nuclear emergency. Emergency managers need to plan for multiple emergencies. And that is all I think I have to say. And my time is up.
Well, thank you very much, Peter. I see some questions and comments coming in. So I'm encouraged by that. Thank you very much. I'm going to save the one specifically on tornadoes till we get into the question and answer period. We're going to move on to Dave Sills. And as I said during the introduction, I'm so happy that we now have a specific group focused on tornado risk. I'll turn it over to you, Dave.
Thanks, Jim. And Jim and I go back a ways. I spent more than 20 years at Environment Canada doing severe weather science, and Jim was my director for a good portion of that time. So he always was a big supporter of the work, and as you can see, Jim, the work's carrying on today, so thanks for that. So this talk is about the emerging awareness of tornado risk. So how it started, how it's evolved, and how it is going to evolve in the future. So I'll talk about work that Mike Newark did at Environment Canada, the pioneering work in looking at tornado risk across Canada, work we did as part of the Tornado Prone project at Environment Canada, and then how we're transferring all that knowledge and now starting a new project at Northern Tornadoes Project at Western University. I'll mention a bit on climate change and tornadoes and just summarize. So here's the work that Mike Newark did. This was published in 1984. He gathered a data set from 1950 to 1979 of all the tornadoes across Canada and tried to construct this map of average annual frequency of tornadoes per 10,000 kilometers squared using the data and some extrapolation. And I've kind of outlined the provinces here so you can see it a bit better. Here are some of the numbers that came out of this work. So again, this is annual number of tornadoes per 10,000 kilometers squared. And it's greater than 0.8 here, so it's a bit of a maximum in Alberta. You can see it's a bit higher in southern Manitoba. The numbers are like Alberta in parts of Ontario and into Quebec and New Brunswick, but he found that southwestern Ontario was the hotspot at greater than 2. The interpolations that he used also resulted in some interesting looking minimum areas. There's this kind of wiggly minimum across Alberta and Saskatchewan, and there's no real good physical reason for that. There's a good physical reason for this minimum here in BC because the Rocky Mountains are there. There's also this minimum across Quebec that's, it wasn't clear how this would get there, just based on the meteorology. So looking at all the data that he collected, it's roughly about 25 tornadoes per year on average that Canada gets. So in 2009 or so, we were asked by the National Building Code of Canada if we could come up with a tornado prone map that could be used as part of the National Building Code. And I was a scientific lead on a team that did that. And the first part of it was to update the number of tornadoes that we get. So we went from the end of Mike Newark's data set from 1979 to another 30-year data set, 1980 to 2009. And that's all of the data points that you see here. And these are all colored by the F scale. So F0 being the weakest, F5 being the strongest. And so that was published in 2012. What we did know is that there's this large area outlined here where we know there are severe thunderstorms occur, but the population isn't there to really report them. We just get very few reports in this large area across Canada, mostly forest and prairie. So we wanted to fill that gap. What we did was use a statistical model, and we used the 1980 to 2009 observations, plus that very good lightning data set that we had from the CLDN, plus population density information, put all that in the statistical model and came out with this new map showing, again, the frequency of tornadoes per year per 10,000 kilometers squared. And here's the outline again, and you can see that we filled in that gap quite well with the statistical model. Now we have 150 tornadoes per year that are modeled across Canada. And instead of having these wiggly minimum areas across areas of the country, we have that one that's across the Rockies, and then one that's to the northeast of the very cold Lake Superior, which seemed to make sense. Something else that came out of this is that the numbers were just slightly higher than what Newark came up with. And instead of the Southern Ontario being the maximum, it was actually Southern Saskatchewan that had the highest number, greater than 2.5. So we had a new hotspot, and we also seem to be capturing less than half of Canada's actual tornado events if the model was correct. So this we needed to verify. And that leads to the Northern Tornadoes Project. That fact that we thought we were missing so many tornadoes, especially in areas away from population centers, really was one of the main inspirations for the Northern Tornadoes Project. And that started in 2017 at Western University. And the main goals of that project were to get a better idea of the actual tornado occurrence and risk in Canada, validate that statistical modeling. But we also wanted to explore methods for detection of tornado damage in those areas that didn't get a lot of reports: forests, cropland, prairie. And what we used these data for are climatology and risk analyses, verifying forecasts, nowcasts and warnings, meteorology and engineering research, climate change studies, and also raising awareness, because there's a lot of public and even some forecasters that don't know that tornadoes can occur as far north as even into the territories. We actually investigated one event in Northwest Territories a couple years ago. Our founding partner with this is Impact WX. They're a social impact fund out of Toronto, and they provided quite a bit of funding to get this project off the ground. The others on the team include Professor Greg Kopp, who's the research chair, and then a combination of meteorologists and civil engineers. And this is unique because there's not another group that really combines meteorology and wind engineering quite this way and does this kind of work, looking at where tornadoes are and documenting them. We also have a GIS specialist, a communication specialist, and then we've got a couple partners at other universities. John Hanasak is out at University of Manitoba, and then you'll hear from Jen Spinney at York University, who is also a partner with the project. When we're partnering also with the Weather Network and other Western students are involved, it's really a community endeavor across Canada in order to be able to detect every tornado. So what are the data sources that we're using? Well, initially, radar and public reports are the thing that tell us where something might have actually happened. A lot of this occurs through social media. So a lot of people that help with the project and our collaborators are sending us messages saying, "Did you see this? Did you see that Twitter post?" And we follow it ourselves, obviously, too. We had a lot of people looking out for where storms are occurring. You can see here, this is one of the first tweets that went out after the tornado went through Dunrobin, about 10 minutes afterwards. So we are already seeing that message getting out 10 minutes after the tornado, that damage had happened. And as Peter showed, this is what the radar looks like as well. So we can track that radar, know where the tornado has been or potential tornado. This is a tool from the US, the multi-radar, multi-sensor system, which maps out where hail paths and rotation paths are based on radar. And this is the path from the supercell that generated the Dunrobin tornado. So you can see it's a very long track, and we were able to examine that track using high resolution remote sensing data, which I'll discuss in a second. So that's the primary damage data source, is the high resolution satellite data that we get from planet.com, 3-meter resolution data that's collected globally every day. So we're able to check a before image and an after image once we know the track and the day that it occurred on, to try to get out a tornado scar like this that we know is a long, narrow track. And that's what'll give away that it's a tornado that caused the damage. We also can fly aircraft over areas that we suspect there was tornado damage. And this gets us down to 5-centimeter imagery. And you can start seeing the direction of trees here, tree fall, and some of the damage that occurs in certain areas. But we do still need to get on the ground. Here's a ground survey from an EF3 tornado in Quebec, where the entire residence was lifted off its foundation and thrown downwind. And a lot of the engineering expertise is to look at the engineering weak points of the construction here to determine different construction practices and how they affect the resilience of buildings. While the people are doing the ground survey, our teams are doing the ground survey, they also now carry pretty much on every survey, there's a drone that we fly. And that collects down to 2-centimeter resolution. And you can see here, you can start seeing the details of the individual trees, identifying the species, looking at the roots, even the soil conditions. So we're getting quite a bit of information after each event. So before the event, one of our meteorologists, Leslie, puts together an event map. It's all the social media data collected, some of the radar tracks, and this is used by the people that go out in the field to know where to go and how everything kind of fits together. As people are out in the field, they use an app for surveying that allows them to use an iPad to take all the photos, know all the GPS coordinates, estimate what the EF scale is and the wind, and we back at the office can see all of this in real time. So this is all used for classifying the event, whether it's a tornado or a downburst, and of course the intensity rating using the EF scale. And we often work collaboratively with Environment Canada on these preliminary assessments. So here's a picture of a map of all of the events, tornado and otherwise, that we recorded from 2017 to 2019. And you can see that they span right across Canada. You can see the tornado count has increased. As the first year when we started in 2017, we were only focused on the forested areas of Ontario and Quebec, so a lower number of tornadoes that we found there. We expanded a bit in 2018 to all of Ontario and significant events outside of Ontario and Quebec. In 2019, that was our first year going fully national across the country and got 66 tornadoes. But we also, you can see, found other events. We call these experimental tornadoes when water spouts occur over the Great Lakes. We're still not including them in our tornado count. Downbursts, 45 in 2019. Non-tornadic vortices, like funnel cloud aloft reports and gustnadoes, lots of those. Unclassified wind damage events where there's just not enough evidence to tell if it's a tornado or a downburst. So a total of 220 events that we investigated and recorded something for in 2019. And you can see by the end of 2019, we had almost 400 events that we investigated. One of the things you'll notice on this map is the big bullseye here with all the activity in southern Quebec. And that was certainly a surprise. And this is mostly due to the fact that there were 3 big tornado outbreaks during 2017 and 2018. During June 2017, there was a 20 tornado outbreak. These are the squares on the map. On the 5th of September in 2018, there was a 14 tornado outbreak. There were circles on the map. And then, of course, the outbreak that we were talking about today, which was 21st of September 2018 in Eastern Ontario and Southern Quebec in diamonds and circled here. So 41 tornadoes in total just from these 3 outbreaks. So that's why there's such a cluster of tornadoes in the Southern Quebec area. So from 2017 to 2019, there were over 89 tornadoes that we discovered, NTP discovered and documented that would otherwise have been missed. And the tornado count across Canada in 2019 increased by 78% by the efforts of NTP. So we are getting those numbers higher as we're trying to get them up to what see if the model was correct and how many were actually missing. Here I've added the 2020 results, so it's 2017 to 2020, and then I've overlaid the contours from that modeling study, and that shows that the maximum is should be in southern Saskatchewan and down and through southwestern Ontario. And you can see that that big bullseye in southern Quebec from 2017 and 2018 certainly sticks out. But this year, the main area of activity, half of Canada's tornadoes this year was down in southern Ontario, and that really shows up here. So we're filling in this part of the map pretty well. And through the prairies, it's been a little more difficult because there's not as much to damage. We did have the Scarth Verdon EF3 tornado with unfortunately 2 fatalities this summer. So that was the strong event, the strong tornado that occurred this summer. But you'll see that we do seem to be getting the same pattern that the model was showing, that there is this minimum that is northeast of Lake Superior because of the cold lake, and over the Rockies. So we're starting to fill in this model forecast, and it looks like it could be fairly good. So let's talk about
3 minutes, David.
Okay, thanks. Let's talk about climate change and tornadoes for a minute. Tornadoes are relatively rare events. The sample size is small. We get far more daily temperature measurements than measurements of tornadoes. The Tornado Archive is beset with non-meteorological artifacts. As Peter discussed, we've got new technologies, new interest. Budget cuts sometimes even affect the tornado climate or the tornado database. So it is difficult to identify trends due to climate change. And as Peter said, if you look at the database in Ontario, which is the highest quality long-term database we have, the number of tornadoes is rising exponentially as we go into 2020. But that's mostly due to our ability to now detect better the EF0 and EF1 tornadoes. If you look at the stronger tornadoes going back to 1900, it's pretty much flat. Not much has changed. So efforts at improving the quality of the existing data and incoming data are really key to building this database that we need to do climate change studies nationally. Preliminary research in the US, though, has noted that while the number of tornadoes doesn't appear to be increasing, how and where they occur may be changing with a changing climate. How being seems like tornadoes in the US are occurring more in clusters, more in outbreaks. So there's less tornado days, but more tornadoes on those days. And where some of the latest research is showing that the traditional tornado alley is starting to creep a little bit east. And that's bad news because it's creeping towards more populated areas. Again, going back to the Dunrobin tornado, in 120 years, no F3 or EF3 tornado has occurred later than the 21st of September. So, obviously that was an outlier as far as how late in the season it occurred. But in general, NTP has found emerging evidence that EF2 plus tornadoes are occurring later in the summer in Southern Ontario. And this trend isn't apparent in neighboring US states, and looking at data that goes back to 1870. So we may be experiencing regional changes in how we're experiencing the effects of climate change. And as the climate warms, the severe weather season in Canada will start earlier and end later. So there is the potential for some regions, especially the prairies, that has such a short season to have more tornadic storms. And again, we'll need more data to know if that's actually the case. So just to summarize, our understanding of Canada's national tornado climatology got a start in the 1980s with Mike Newark's pioneering work. It was updated in the 2000s for the Tornado Prone Project, and it's once again improving as the Northern Tornadoes Project endeavors to detect, assess, and document every tornado that we get in Canada. And the website to see all this data, it's all open access, uwo.ca/NTP. And climate change will undoubtedly affect the tornado climatology of the future, but trends will likely be regional. It could be up in some regions, it could be down in some regions may not change. And it may take many more years of high quality data for all of that to become clear. Thank you.
Thanks very much, David. Fascinating talk, certainly very, very interesting. And our next speaker will be Jennifer Spinney. The work that Jennifer does on societal response, it's a field that certainly, as kind of Gordon talked about when he joined as a forecaster, and certainly when I did, societal research was not considered. Really, most of the work we did was on the physical science. It's really refreshing that there's more and more scientists like Jennifer now joining the teams, because really, when you think about it, it's the people that are impacted, and it's the people that need to respond to severe weather and extreme weather events. And it's nice to see the work that Jennifer's going to share with us. So go ahead, Jennifer.
Okay, thanks, Jim. Jim, can you hear me and see me? Thumbs up?
Yep.
Okay, fantastic. Thanks for the introduction, Jim, and thank you everyone for being here today. I'm very excited to have the opportunity to speak with you about some initial insights I've made after having conversations with affected residents or those people who experienced the Dunrobin tornado on September 21st. As Jim mentioned, I'm an assistant professor in the Disaster and Emergency Management program at York, but I'm trained as an anthropologist, and I will be bringing this social perspective to the forum this afternoon. As an anthropologist in my research, I apply my training, my sociocultural and linguistic anthropology training, to understanding the human experience, and specifically as it relates, for the last 10 years anyway, to the human experience of severe weather, hazards, and disasters. And today I'll be talking with you about one of the 7 tornadoes that traveled through the region on September 21st, specifically the Kenburn, Dunrobin, Gatineau tornado. And as was mentioned, this tornado traveled through the area just before 5 p.m. on Friday, 21st of September. So that's the end of the workday, the end of the work week, and just the beginning of Carp Fair weekend, which is a massive annual celebration that the community often participates in. Lots of family activities, it's a fairgrounds, so things of that nature. People were gearing up for Carp Fair weekend. And most of the perspectives I share with you today, again, will be centered around conversations I had with people living in Dunrobin, since this is the area, or the community rather, that we targeted in our research. Now, when I say we, it's important to highlight that this presentation is based upon a larger research project that I've been working on, one funded by the Northern Tornadoes Project, or NTP. And it emphasizes trying to uncover the social life structures or social aspects related to structural recovery specifically. And not only for Dunrobin, but also for the tornado that went through Angus in 2014. And the purpose of this larger project is to help NTP develop strategies for enhancing long-term recovery, and also to help them develop mitigation strategies to protect people from future storm activity. But since I'm a social scientist, I approach this research project using a qualitative methodology. So that means I carry out semi-structured interviews. Because of COVID, I've been doing that over the phone or over Zoom. I've had 17 interviews so far with 23 participants, and that occurred between August and September of this year. Interviews lasted anywhere between 60 and 90 minutes, and all of those interviews were audio recorded and then transcribed verbatim. And so today I'd like to emphasize that what I'm sharing with you are just these initial insights, that analysis is just beginning. And I'm excited to talk with you about how affected residents described what they were worrying about during this experience and how they coped in the days and months afterward. To give you some more context about who participated, and also to sort of situate the perspectives that I'll be sharing with you, I thought it would be helpful to offer you some characteristics of the participants in this study. So you can see that the participants experienced a range of tornado strength winds. They were of different ages and stages in life, that the sample comprises both females and males, that participants were, some were living with their children and some were just living with their spouses. Only a slight majority of participants were located at home during the tornado. And of the 16 participants who were displaced because of the tornado, people moved back in anywhere between 4 months and 17 months following the tornado disaster. And so these variables, along with others, influenced their tornado experience and the worries on their mind during the tornado and again in the days after. Now, it goes without saying that experiencing a tornado contributes to a huge range of emotions, and that was certainly the case with residents who so graciously shared their time with me and talked with me about the traumatic experience that going through the tornado had for them. Residents commented on being overwhelmed with feelings of worry about their children and their pets. They were worried about being homeless. They were worried about, where are we going to go tonight? Where are we going to go in the next while? And what is the status of our house? Our house is in disarray. Our bedrooms are in the living room and our living room is in the kitchen. So there was a huge amount of shock that people experienced, of course. There were people who weren't at home during the tornado, like I said, and communication had broken down, and so they weren't able to reach their loved ones. And this brought on significant worry as well. And of course, others talked about leaving their homes open and exposed to the risk of looters who might have the chance to come through and take whatever items were left. Now, the worries brought on by the tornado continued to build over the weekend, and by Sunday, these worries were framed more as questions. Questions like, what will the rain do to my house? Because the forecast in the days following the tornado called for huge amounts of rain, and so this was a cascading risk. People were already having to experience the damage brought on by the tornado, but now also having to prepare against the risk that the potential rainfall might have on whatever was left in their house. What is the integrity of my house? Can I move back into my house? Will I have to tear down my house? I hope I have to tear down my house, some people were thinking, because is my house even safe any longer? Others didn't know how they would even begin the process. And so by the end of the weekend, many, if not all, had already been in touch with insurance and their service providers. And in some cases, like what resident 5 describes here, it only contributed to more worry and more frustration. Residents also, very importantly, talked about media presence, and especially for those who weren't at home during the tornado, seeing damage to their homes for the first time on the television or through news articles was extremely upsetting. And so, if you don't know, when the tornado happened, residents were escorted out of the community and the community was closed down. And residents were only permitted to re-enter the community, to visit their property and see the damage firsthand on Sunday afternoon. That was the earliest time for most, if they couldn't somehow sneak in earlier. And so where residents weren't permitted to be on site, media was permitted to be on site. And so it generated a lot of sad feelings and frustration when residents were seeing what was happening at their home through the media's eyes. Now, by Monday, residents were beginning the long process of cleanup and recovery, which meant organizing lodging. They're trying to organize work schedules, and they're meeting with all kinds of insurance representatives, disaster restoration people. And during the process of tabulating losses and determining what's salvageable and what's not salvageable, you can imagine the challenge that resident 1 had when she's sitting outside in her car, watching as the people started emptying the house and everything that ever meant anything to her into the dumpster. Now, one resident located outside of the original damage path experienced extreme worry and frustration. Now, if you weren't in the official damage path, as this resident wasn't until November, when the official damage path was expanded to include their community, you could not register for nor receive any type of assistance from volunteer groups, Red Cross relief, or access to health services. Being part of the official damage path meant that you were eligible, that you could register and get on the list. Getting on the list was key to having access to everything. And even though residents who participated in this project have returned home and all of them describe how happy they are to be at home, they still have worries. Some are still experiencing challenges with insurance. Every time the wind starts blowing or they hear that alert on their phone, participants often comment that they become triggered, that it generates anxiety and worry in them. Now, restrictions associated with COVID have created additional delays for rebuilding and sometimes for refinishing, right? So participants, when COVID started, most participants had moved in, but they couldn't have contractors come in to install blinds or finish flooring, those types of odds and ends that are still critical to the rebuilding and recovery process, but that COVID has compounded and made more difficult. One participant during our interview, she opened up our entire conversation by sharing her feelings of guilt, which suggests to me that she still struggles with having not been there with her children during the time of the tornado. Now, I give you this background on worries identified by participants to give you an idea of what these residents were dealing with: that shock, the uncertainty, the trauma, the cascading impacts, and just the sheer exhaustion of having to cope with all of this and to recover from it. Now, to provide aid and relief as affected residents coped, several organizations convened in the community almost immediately to offer their services. And this brought a tremendous amount of relief to people on the ground in this overwhelmingly uncertain situation. But one resident commented that even though the right feet were on the ground, in those first hours, in that first night, the disaster response was not geared to meet the unique needs brought on by this situation. They were winging it, this participant said, and there has to be a playbook for disasters of this scale. Now, charitable organizations, of course, were also involved. Residents commented positively about the Mennonite group who came and helped clean up, tarp their roofs, put boards up to protect exposed walls. The Samaritan's Purse came and cleaned up properties, cleared out the roads, I believe, and United Way was especially complimented for the gift certificates that they gave to affected residents. But what also came through during conversations was a strong negative sentiment towards the Red Cross and their response during this time. Another group, West Carleton Disaster Relief, was huge in terms of being there to offer a coordinated relief after the tornado. One particular element that they included in their efforts was setting up a community contact for each of the affected residents, which at least one resident commented as being extremely helpful. What the West Carleton Disaster Relief Association may have been criticized for was the perception of not enough transparency, I guess I would say, in terms of the distribution of donations that were given to help affected residents. And so what I have interpreted from these accounts that residents shared is this perception of unequal distribution of funds. Residents also coped by having support of individual volunteers, so farmers, employers were very helpful in saying, take the time that you need. There were arborists that came in from other cities to clear the roadways of trees, and friends and family especially, who offered lodging and meals and just all kinds of support, as resident 14 describes, about just grabbing them by the shoulders and saying, you're going to get through this and we are going to get as much out of here as we can. Basically, we're in this together. And then also there were local businesses, many local businesses who helped residents cope with this by donating meals. As resident 4 describes here, a representative from a local business came with their pickup truck and just dumped out all of this equipment and said, tell all of your neighbors it's free and they can help themselves. And this was extremely helpful, again, especially as residents were preparing for those heavy rains. Residents also employ different strategies themselves to help them cope. Something that stood out quite a bit was this adjusting their mindset whenever possible. The idea that using quick thinking helped them to manage the situation. And the idea being here that you take charge, you get after it, you have a plan of action, and you just work towards that goal you have in mind. Now, oftentimes during conversations, when we were talking about worries and how people were impacted, residents would often follow that with how grateful they are, the generous support that the community gave them, that they couldn't have done it without the community, how lucky they actually felt they were because it could have been much worse. And so I attribute this to being more of an attitude of gratitude, and that this has been helpful for them in trying to manage the situation that was unfolding and that they've recovered from. Another resident commented on the need to fight, and that the process of getting back home, it was so horrible. You just had to fight every single day. And so this mindset of having diligence and stamina, the mental fortitude, it was very important for at least one resident to manage what was going on. And then lastly, one resident adjusted their mindset by shifting from a frame of victimhood to survivor. And the idea here being that she can do anything now because she survived this. If she can survive the tornado, the EF3 tornado, then she can really survive anything.
3 minutes, Jen.
Okay, thanks, Jim. Now, preliminary review of conversations also illustrated other actions affected residents took, such as buying tarps and bins or ordering storage containers, for example. Being in the community was critically important, not only in those early days where you're finding information or you're learning what's happening in terms of when can we get back in, or how safe is it to get back in, but long after the tornado, when residents who might have rented a home outside of the community, it was really important for people to be as close as possible, to have that sense of familiarity, this sense of shared experience, and the ability that others around you really understood what you were going through. That was very important. Okay, now because I'm short on time, I can't share all of like the ideas that residents have already talked about in terms of what was helpful, what kinds of things people could do in the future to help themselves cope better, prepare better, respond better. But what I'd like to do is just say in closing that what I have shared today is just a snapshot of how residents coped with and managed their response and recovery after the Dunrobin tornado. And the preliminary results shared today show particularly the challenges that the residents had, the breakdown in communication, the uncertainty of not knowing what to do, where to start, or how they would even be able to recover, expose that fragmentation that Dr. McBain was referring to in his opening talk. And as much as we need to create a disaster response strategy at the global scale that matches the integrated nature of hazards, risks, and challenges that we are increasingly facing in society, this type of integrated strategy is also needed at the local level. And I contend that we can learn from these local perspectives, from what residents feel went well, and also from the challenges that they experienced too, so that we can generate a community-informed approach, so that we can use these perspectives to create considerations or actionable advice for how to build a more integrated disaster response strategy. And I'd like to say last that in doing so, we have a tremendous potential benefit for helping communities better manage future tornado threat. And it's a valuable step towards reducing societal impacts and increasing that overall social resilience that we're striving for. And with that, I'd like to thank you. And of course, I'm open to any questions or comments that you might have. Thanks, Jim.
Thanks very much, Jen. That was really powerful. Certainly the personal stories you shared are extremely, I mean, the messages that came from those people are extremely important and, they said, very powerful. And perhaps we'll get some time for you to elaborate on some of those detailed coping strategies that you didn't get a chance to talk about. So we've got about 45 minutes for questions. And folks have already indicated a number of questions, and I'm going to start right away. The very first question was asked by Rick, and I'm going to direct this to Gordon, but Jen and others may also want to comment on this. Basically, Rick has pointed out that costs, as Gordon suggested, due to disasters are increasing rapidly, what someone might say exponentially. And the question that Rick had was, how much of it is actually due to the changes in habitation, which is vulnerability and exposure, versus the actual increase in the intensity and frequency of extreme weather that might be actually due to climate change. So I'll let you, Gordon, have the first shot at that, and then we'll turn it to other panel members afterwards.
Well, thanks, Jim. That's a very important question, Rick. The reality is I don't think we can actually put a real specific number on it, but it is certainly very important that the increasing cost of these events is related to the structures, the people, if you look at the numbers globally, what you see is a huge economic cost, or at least in insured costs and non-insured costs in, say, well, the United States, Canada to some extent, parts of Europe. Whereas you see the number of deaths, the people who are displaced from their homes, their farms, or whatever, is huge in parts of Asia and parts of Africa, particularly. And so we're seeing and I would, let's say I had about 9 more slides I was going to show instead of that one, but decided that Jen wouldn't give me enough time for that because she's smiling, or Jim. But it's very important, and that's what we're trying to do in some of these projects. The international programs on Future Earth and integrated research on disaster risk are working together to try and identify not just the dollar costs as seen by insurance companies, but the real what you might call the social dimensions of these. And they are really horrific as you're getting increased numbers of people who are displaced. I mean, I do want to say, though, in my opinion, in the opinion of most climate scientists, is the number of extreme weather events is going to go up. You look at the reports of the Intergovernmental Panel on Climate Change, we're going to have more heavy rain events, particularly more hot days. The number of high intensity hurricanes or typhoons, even though the number of hurricanes and typhoons is not projected to increase very much, the number of the high category hurricanes and typhoons is expected to, and is projected to increase. So we'll see more hazardous events, but we need to work on, as I was talking about in my slide, I referred to exposure and vulnerability. We have to deal with the exposure of people and property, infrastructure, and particularly work on reducing their vulnerability, knowing that these events will happen. How do we make it so that it doesn't cause a disastrous event? So I'll let other people comment on this, but that's a good question and something we need to address, let's say, scientifically, including the social dimensions, very much the social economic dimensions, but also I think there needs to be a political attention to these issues of adaptation, disaster risk reduction, etc. Thank you.
Thanks, Gordon. Jen, do you have any comments on that? Good question.
No, not at the moment. No, I may, but I'm just organizing myself. I have something that I've been looking through to help provide a response. So if anyone else wants to take a stab first.
Dave or Peter? I will say myself, it's a great question. And one of the challenges, and I guess if you look at what Peter and Dave presented and the discussion around climate change trends with small scale events that are difficult to detect, it's really often a challenge to actually find trends. And I know in the business I'm typically in hurricane forecasting, it's very difficult to detect any trends because the number of hurricanes has increased substantially because we can now detect them since satellites. So you look at the pre-satellite and the post-satellite climatology of tropical cyclones, which made a big difference. And so, I always say it's a mixture of our vulnerability, where we live. Let's face it, more of us are living in cities, more of us are living in coastlines, and there are more of us, and we own more stuff. I mean, the story I always say is I've got 2 cars in my garage. I got a garage with so much stuff in it, I can't put my cars in there. I've got a finished basement with stuff in it, whereas my grandmother had a shed, and my grandmother had preserves in her basement. And so when I've got insurance guys here today because I had a flood in my basement, the impact is considerably different and the costs are considerably different because our vulnerability and our exposure has gone up. So it is certainly a combination of the two. So I'll leave it at that. Oh, go ahead.
A comment, yeah. So what I wanted to say was that I don't have specific statistics or anything to quantify whether it's one or the other, but I do know, and this is following on what Gordon shared and what you also shared, Jim, that there's a desire for people to live in places that make them and the area more vulnerable. We think of retiring down to Florida, or it has huge implications for when severe weather comes through. If you can think of hurricanes and trying to carry out mass evacuations in advance of a hurricane, the more people that are in that vulnerable location, it's not impossible, but it definitely complicates the situation. We have people who prefer to live on the shorelines of rivers. So we've talked a little bit about the big floods that happened along the Ottawa River. And I'm looking at a project, or I'm working on a project that's focusing on local perspectives of the 2019 flood catastrophe just west of Ottawa in Westmeath, or Whitewater, region township. And so this desire to live on the shorelines is somehow it's creating situations where people are more vulnerable. And then also the way that we're building our cities. So we think of a city like Toronto in this massive scale urbanization that's happening in that city. And it's kind of just being plopped on top of aging infrastructure, which is creating big challenges. I know it does in terms of urban, this non-river style flooding, where just minor amounts of rainfall are creating huge impacts. You know, flooded condo buildings and flooded underpasses. You know, it's just, I don't have a strong statistic. I just know from what my experience is in this world that we seem to be moving more towards living in vulnerable places and kind of accepting vulnerability, and we would benefit from shifting out of that.
Absolutely. Thank you, Jen. So we had I won't call it a question, but I'm going to turn it into a question, and I'm going to direct this to Peter. Kent commented that it was really a shout out to what I think is a Facebook group, the Ottawa Tornado Watch, and the fact that they really kept people informed during the event. And so Kent was really thanking that group. And then I assume Adam Skidder is involved in that group because he was grateful for the comment made by Kent. And so the question that I'm going to turn that into for Peter is that social media has really changed our world, let's face it. And social media can be very positive. It can be very valuable in helping get the message out, but it also can provide a challenge because there's lots of misleading posts on social media that make it difficult for the official message to go out. And so I wonder if, Peter, if you've had any comments, you may know specifically of the work that the Ottawa Tornado Watch group does, or the Ontario Tornado Watch group does. But if you have any comments, maybe specifically to this group or those kind of, I mean, I do it myself. I do a lot of social media. So what are some of the opportunities and valuable aspects of it? And what are some of the challenges from your perspective?
You know, I haven't met Adam, nor do I follow Ottawa Tornado Watch or any of those Tornado Watch sites a lot. I think maybe I'll make a couple of brief comments and then pass it over to Dave. I think Dave probably follows them more. But I would say that for the most part, most of these folks I view, I think our office views as partners, because to the extent that which we can, you know, get the message out, it's all good. And I don't think that there are any groups that I know of that issue warnings to supersede ours. I think that it's fairly well recognized that Environment Canada has the mandate to issue warnings. But I think that, you know, if other groups, you know, use social media to further disseminate our message, you know, great. That's really my comment. And maybe Dave, you want to add anything to that?
Sure.
Please, Dave.
Yeah, I know Adam well, and we used to be neighbors actually. You know, the service that they provide is different than what Environment Canada can provide. They actually, you know, will watch the radar 24 hours a day and have people just staring at it, looking for any kind of rotation. And, you know, so they'll get the jump on things sometimes that Environment Canada may not be able to, but you know, it's very focused on that. And the benefit for us with NTP is that it has, you know, I think 200,000 plus members. And all of those people that are following those storms also start providing reports about what they've seen and any damage and that kind of thing. And Adam's been great about sharing those with us at NTP. And, you know, it makes up a large portion of those incoming social media messages that tell us where to look for storms. So again, with NTP, we really look at this as a community endeavor, and there's a lot of different groups out there, including Adam's group, and it's now called an Instant Weather, that contribute, and we need all these people in order to be able to get a real handle on what's going on across the entire country, and we can all work towards the same goal of improving prediction, improving our knowledge of where things happen, and recording them and documenting them.
Thanks, Dave. Jen, do you have any comments? Because social media is such a human, societal kind of aspect to it, just in its name. Do you have any thoughts on where it might be, the value of it, and how we might actually take advantage of it to improve societal response?
So to be honest with you, Jim, I was responding to a question in the chat. And so I don't know what was shared prior to you asking me that question. And so if I repeat something, forgive me, but I think that it can be an asset, but it needs to be, it's like a tool, but could become a weapon, right? It needs to be used very strategically and very carefully in terms of sharing the appropriate message in the right kind of language with the right amount of context, and to give people the information they need to make the best decisions. But sometimes there are challenges with that. Sometimes, there are word limits. Let's say in Twitter, you can only make a tweet so long. And I think while social media is powerful, I imagine that people are using a cell phone in order to be able to access those social media sites. We seem to have an issue, especially in that region. Residents, at least in the Dunrobin and surrounding area, would talk about cell phone coverage as being very inconsistent. And the same goes for people in Whitewater Region Township. So if we're wanting to learn, if we are thinking that residents are going to learn about the potential for storms or tornadic activity through social media, even these emergency alerts that are coming through, if we're thinking to use that as a tool to warn, I think more needs to be done to enhance the infrastructure that we're relying upon. And that's just a first step. So I'm sorry if I repeated something that anyone had said.
That was very good, Jen. Thank you. We have one question that actually has been answered. So as Jen was doing an answer on chat, actually somebody from NTP had answered one of the questions. I'll just summarize it quickly for anybody who's not tracking the chat. But Andrew had asked about, and Dave showed the nice pictures of drones and some of the damage assessments. And Andrew asked about the challenges in quick response from either Transport Canada or NAV Canada. And Connell, who works with Dave, responded that NAV Canada does have a flight authorization request system, so that within 6 hours you can actually get approval. And certainly that has helped folks like Dave and others get the drones in the air, and certainly help with some of those post-damage assessments, especially for small scale events like tornadoes. So we have a number of questions that are quite detailed in detection, trends, prediction. The first one is from Travis. And Travis has asked, first of all, Dave alluded to the fact, I think, Dave, that lightning trend has been going down over the last 20 years. And Travis wondered, have we been using the same system over the last 20 years to detect lightning? And is there biases? Because inherently you'd think that with climate change, the thunderstorm activity might actually increase. So is there biases in the lack of detection of weak lightning events? Are there other biases in how we detect lightning? Or is there some explanation why lightning trends may have gone down over the last 20 years? And so I'll let Dave start at that one.
Actually, it was Peter who mentioned that. So
Okay.
maybe I'll let him
Oh, it
start
was
to answer
Peter.
that. I might have a couple comments afterwards if he doesn't cover it.
Okay, sorry, Peter.
Well, I think the program, the Lightning Detection Network, I think began in 1998. And I think that there were some instrumental changes in the early years. And maybe Gordon McBain might be able to confirm that because you were probably the ADM at the time. But I think the first few years, yeah, there were probably some instrumental changes, but for the most part, I think it is detecting cloud to ground strikes, and the network is quite robust. And I think that we have to basically look at the data fairly factually, as it has gone down slightly. And Dave does use lightning data in his analysis in terms of detecting tornado climatology. So it's a bit, what's the word, disingenuous to say, well, we should use it for tornado climatology, but not the trend. I think the trend is down, which kind of does raise the question, well, should we assume that, severe weather is also going up in Canada? And the answer is unclear. And all I'm showing you is that the answer may not be necessarily it is. In fact, the answer may be it's pretty static. The EF2 to EF5 tornado days that I showed was also fairly flat. Dave showed that as well. So what I'm showing is, what I'm getting at is, while the research suggests that things will get worse in the future, it's not clear to me that it has gotten worse in the last few years. Let's put it that way. Certainly that's true for tornadoes, and lightning detection kind of suggests that it's not that much worse now, even with heavy rainfall. But that gets into another whole realm of research, and I'm not the guy to answer those questions. I'm just kind of raising the issue with showing that data.
Okay, Peter. Dave, any thoughts on the lightning trend?
Yeah, the lightning network actually has increased in quality as we've gone along. And if anything, we should be detecting more lightning now than we did when it first started, especially if we're talking about total lightning, which is combining the cloud to ground with the in-cloud lightning. So I'm not sure what Peter had plotted there, but there's different aspects of lightning, and you can plot lightning days as opposed to lightning. So I'm not sure what the trend is there. Was it based on days or lightning events? But and again, it could be like tornadoes, where there may be less lightning overall, but it doesn't mean that there's less storms overall. Just the behavior of the storm could be changing, where there's less lightning, but it still can create the same amount of severe weather. So these are the things that you've got to look at. You've got to put all this data together. You've got to look at the trends and how they intersect. And it's not easy. The one data set in Canada that's really nice for this kind of thing is lightning, because it's been around for since 1998, and we have millions of lightning detections. So that's why we use that as part of the statistical modeling for tornadoes, is because it's such a nice data set. But what we want to do with NTP is bring together all the different severe weather data sets and see what the trends are and how they fit together.
Thanks, Dave. And I know that although we have a national lightning network, the CLDN, I mean, there are places in the country that have their own lightning networks, the North, for example. And depending on what data set you're using and whether or not the North is included or not, some folks don't realize there's a lot of lightning that takes place in the North. Mm-hmm. And it may or may not be part of some of these trends. And as we know, with climate change, the North is warming faster than the South. And so when it comes to the likelihood of a thunderstorm, the actual likelihood of a thunderstorm may actually be going up significantly in the North, but the detection of that may be a challenge, especially with gaps in something like the lightning network. And until now, I hadn't even thought about the North-South question when it comes to the detection of severe weather and something like using the lightning network. And Dave, do you know, or Peter, if our lightning network, how far it extends to northwards?
Yeah, I mean, the CLDN does a pretty good job up until maybe 55 north or so, and then it starts to fade out. But there is another data set that Vaisala offers, which is the company that provides CLDN for us, and it's the global lightning detection system. And it uses slightly different technology to detect it globally. And when you look at that data, you start seeing quite a bit more lightning activity over the north. So there are different ways, different lightning data sets, different ways of detecting lightning. And if you want to see the data that's up there, you can. I mean, the data are there now to be able to see that kind of thing.
Perfect. Thanks. Again, as I said, there's some more questions on detection and prediction. One of them, Len asked about is there a bias in detecting tornadoes in forested regions? So, you fly a drone over a forested area and you can see the damage. And as I say, there's a lot of moose pasture in Canada, but there's also a lot of prairie area and a lot of treeless areas. So is there a bias in the forested areas in the tornado climatology?
Not sure if he means a high bias or a low bias, but I mean, up till now, it's been a low bias because the population hasn't been there. The moose aren't calling in on the cell phones. So, it's been a low bias, but now when we're looking at satellite data, and actually we've got, one of our meteorologists has divided up the country into boxes and going box by box across the country, looking for evidence of tornado scars in all of the satellite data going back to the late 1980s and finding lots of tornadoes. So it is one area, the forests, that you can really see the impact of downbursts and tornadoes. And you can, over time, see how that changes. So some of the tornado scars, even if they're not fresh, the growth around that area is affected for a generation. So you can go back quite a ways and still see the scar there. So again, I'm not sure if the intent is positive or negative bias there, but it's forests compared to prairie, yeah, you'll be able to detect tornadoes much easier in forests with satellite data. But we are working on ways to do that with the prairie as well. There's some of the satellite channels are actually kind of vegetation health channels. And so you can see where tornadoes have gone through crops, and that registers on that channel. So we are working on ways, new ways, innovative ways to extract data from those prairies that will tell us how many tornadoes are occurring there.
And the other thing, and I never thought about it until you started talking, Dave, about moose pasture, as I alluded to. In the forests, it's a lot more difficult if there are people there to actually see a tornado coming, whereas in the prairies, you can see them potentially for miles, and you see a lot of the spotters, the chasers.
Yeah.
They're chasing in flat country or exposed areas. And last week, I think it was last week, there was all those water spouts in the Great Lakes, and of course, they're not going to leave any track. But if it wasn't for humans taking pictures of them, we wouldn't have any documentation of all of those water spouts. So it's a fascinating challenge. That's
great. I mean, with that water spout outbreak, it's now the most tornadoes that have been, or most water spouts that have been recorded in the Great Lakes in an outbreak, according to water spout Wade Zalegi. So, so it's, and he's got the interest of a lot of people to go out and go to the shores and look. And he's actually got a model developed now where he can tell people that, the next few days are going to be big for water spouts. So people are getting out there, like myself, and seeing if you can see them. And so again, it's the technology and the awareness is really increasing the number of events that we're finding.
Exactly. Speaking of models, Peter asked a question on, we're seeing an improvement in high resolution modeling. So we've got the GEM-LAM, we've got the high resolution models in the States and various WRF related applications. So I'll start with you, Dave. Are models getting to the point that we could actually predict, well, I don't think we could predict necessarily tornadoes, but do you have any comment on the likelihood of being able to predict tornadoes using a high resolution models?
Sure. One of the things we do with NTP is we have our meteorologists do a daily 2-day tornado outlook so that our field teams are aware of when they may have to go out and fly across the country. So we are looking at all of the models every day, all summer long. And, you know, there's definitely an increase in skill as far as identifying tornado environments. And, you know, the models can do that as far as, you know, looking at the synoptic scale, saying that, you know, this large area has got the ingredients necessary for a tornado to develop. Now, where it gets harder is, you know, when and where will that storm develop? And that's where the high resolution models start to come in. But if you start to look at there's many different high resolution models now that focus on areas of North America, and we can look at those. And you see that the solutions are all very different. So you tend to use those in an ensemble way. They're actually ensemble high resolution modeling systems too, to do exactly this. And that is to just try to get an idea of the uncertainty, kind of the convective mode. Are we talking about isolated supercells or squall lines coming through, those kinds of things? And those models tend to help quite a bit with that, as far as, you know, the convective mode, the timing. Some of them do, they have the ability to say whether it's a supercell or not that's occurring. The tornado risk is not, you can't model that unless you get way down to you know, 100 meters or so as far as computer resolution, and you can't really do that in real time. But the ones that are, you know, a couple kilometers or a kilometer resolution, they're getting the ability to see a supercell that, you know, that may generate in certain areas. And if you see that there are several of these models all saying the same thing, that certainly perks your ears up if you're looking for tornado potential. So again, those are the tools that we're using every day to assess tornado potential, and it's those tools also that the forecasters at Environment Canada are using as well.
Peter, do you have any comment on the tools you guys are using on the Severe Weather Desk?
I agree.
I agree too. No, thank you. That was a very good question, and nice thorough answer, Dave. Fred, who I haven't seen in a long time, has asked a good question. I'm going to start actually with Jen and then to Peter. And Fred talks about the fact that, you know, there may be 10 severe weather watches in and around the area that he lives per year, and 5 warnings up, you know, but the likelihood of actually seeing a tornado is pretty small. And, you know, you always run the risk, depends on the size of the area that we put out for a watch or the size of the area that we include in a warning. But there's a risk of too many false alarms. And I don't know how many false alarms there are, but there's a risk of false alarms actually resulting in some complacency and people not taking the kind of action because there's too much warning going on. We face the same thing here in Atlantic Canada when it comes to hurricane warnings, because the severe damage is usually only in a relatively small area, but the actual area warned is actually relatively large. So from a societal perspective, I'll start with Jen. Like, have you looked at any of this challenges with respect to how we warn and how false alarms might impact effective response?
Have I looked specifically at the impact of false alarms? Not specifically, but I could say that based on my experience talking with residents, you know, many years ago after the Joplin tornado, with Dunrobin and area residents after this particular event, that what you say is true. The perception that we get these all the time and nothing happens. The perception that even though even though the weather might look bad, we get microbursts here. We don't, this is what some people were saying in Dunrobin. We get microbursts. They have this perception of how the weather travels through the area, it comes through the valley. But the perception was not that anything terrible would happen that day. People would get the warnings and still leave their house to go get their wives from work. They would see the sky or receive the warning, and they'd still go out on the front patio or the back porch to look and see what's happening. I heard from residents in Dunrobin that even during this most recent season, so in August, there was at least one tornado warning, and that came up in all of my conversations, the impact that warning had on residents. But overwhelmingly, there was still people, at least, sorry, not overwhelmingly, but at least a few who commented that they still stood out and watched. They waited upstairs to see if anything was actually going to happen. So I share all of that to signify that I'm not sure what the answer is, because whether it's a matter of these things don't happen here, or whether it's a matter of these things have already happened here, but now we have a new warning, it seems like this similar challenges persist. And we definitely need to work on strategies to enhance people to take protective action, but I'm not exactly sure what the best answer is to that.
Peter?
Okay, so I think there's three I have three answers to that. One is education, I think, is part of the answer. Like, for example, educating people what the difference between a watch and a warning is. That's kind of what I talked to earlier. So that helps. A watch is not the same as a warning. A warning is a higher level of severity. So education is one part. The other reality is that it's a challenging endeavor. As I mentioned, it's just very challenging to forecast, to warn for tornadoes. They're very, very small beasts. There are a lot of storms that will not produce tornadoes that we think will. So false alarms. And then there are the smaller events, like, for example, like Orleans, actually the one that I saw myself last year, June 2nd last year. I saw it with my own eyes. We didn't have a watch out for it. We didn't have a warning out for it, and it happened. So it's a balance between forecasting something that we think will happen and not overwarning. This summer, for example, there were 2 false alarms in the Ottawa area. We put out tornado warnings. Nothing happened. Well, there was one small event apparently far south over Kempville, but so it's a balance. And there was a third point that I wanted to make, and now it's escaped me. So, yeah.
Can I add to that? Thanks for that, Peter. Can I add to that, Jim?
Sure, go ahead.
So I think education is important, and for people to understand the difference between a watch and a warning, I mean, that's critical, right? And that also came through in some of the conversations I had with residents, where at least one was commenting like, what's the difference? But I think it can't just be about people learning the difference or having them become more educated. I think there are definite areas that we could improve upon in the ways that we warn. And this is based on my experiences talking with people over the years. For example, like this idea included in the warning, I think there might be the language if threatening weather approaches. And so for me, this is an ambiguous type of statement that is defined differently across, neighborhoods, across cultural groups. People are defining threatening weather differently. So I think if the language in the warning could indicate what threatening weather is, then people could then identify what they're seeing in their environment, understand this is threatening weather, this is what they're talking about. Also, at least one Dunrobin resident talked about how there's no ending to the warning. You don't know when the weather threat is over. At least those types of alerts don't come through, right? The alerts signifying when weather is happening come through, but there's no indication through an alert when that threat has passed. I mean, these are just a couple of ideas that I would say are mostly informed by what I'm hearing.
Yeah, the third point I wanted to make, just remembered what it was. Now, the thing is, part of the problem is that our forecast regions are quite geographically large. So this is maybe something that David's going to talk about later, but Ottawa, the region of Ottawa, for example, is divided into Ottawa North, Ottawa South. But Ottawa North is actually huge. Ottawa South is actually huge compared to the size of the actual tornado. So we are evolving. Environment Canada is evolving towards a new methodology whereby we would kind of polygon the warnings, like the States does right now. In other words, instead of saying Ottawa South, we'll actually say it's within this particular part of Ottawa South. And then that would trigger the wireless alerts in that particular geographic zone. That's a project that's been ongoing for a while. It's still ongoing. It's technologically complex. We're not there yet, but we're getting there. And I heard your comments, Jen.
Yeah, and Arn Ashton wrote in the chat. He was mentioning that including communities in the tornado path could be of good assistance. And that's something I'm happy that Arn brought that up, because that was another point I wanted to make, that sometimes people are just not aware of the area that, they see the area in the warning, but they don't realize where they are in relation to that area. It's not always so well known, but they do know the community that they're in.
Yeah, and that's another thing is, like you said, mentioning the communities in the path of is something that we're doing. And in fact, we did that on September 21st. We actually mentioned communities in the path of.
Oh, that's excellent.
So that it does help, but of course that relies to a certain extent on people getting the message, which involves communication strategies and cell phones and wireless alerts and everything. So anyway, I'm going to pass it on to someone else now.
And Gordon, did you have something
to that?
Yeah,
Okay,
I
Gordon
wanted
first.
to,
Okay.
Gordon here, the other Gordon, anyway, this Gordon, just wanted to comment that, well, first of all, as we've been trying for years to get sort of a better discussion with the communities as to how do we inform and warn them. And I just wanted to say, since we're almost done, one of the issues of which I was sort of alluding to was the need for a more integrated approach. We have in my opinion, the unfortunate situation in Canada where the Met Service does the weather warnings, heavy rain, tornadoes, etc. But the provinces or regional conservation authorities, whoever, do the flood forecasting. We've seen cases in Canada where the weather forecast, according to not me, but John Pomeroy, for example, in the case of the Calgary flood, said, the weather forecasts were right, but the flood forecasts, first of all, weren't well matched with it, and they weren't communicated. And we need to have a more integrated approach. When I was ADM, in the 90s, we were doing, excuse me, weather forecasts of heat, for example, with air pollution forecasts in Atlantic Canada and health messages. And when I discussed this with the Ontario government about doing it in Ontario, I was told by the province that the minister said, if you did that, we'd be taken to the Supreme Court because, quote, natural resources are the province's responsibilities. And I think we do have an unfortunate breakdown between different levels of government that is sometimes politically changes with time, but nonetheless, we need to have a more integrated warning system. And a talk I gave recently at some other I think it was the American Met Society conference was, as we're looking for predictions, we need to figure out how do we inform and where appropriately warn our citizens and for the next day, but also the next week, the next month kind of thing. And that means we need to have a better way of integrating the changes in the weather of our prediction, but also the changing exposure vulnerability. If it's in the summer on a hot day, they might be more likely to be outside, whereas other days they're more inside and that kind of thing. Anyway, I'm just saying it's a complex situation which is constrained by different mandates of whose responsibility it is, that kind of thing. So we need to, let's say, find a way of better doing this and bringing in more of the social, economic, and other dimensions of this so that we can warn and inform more appropriately. Thank you.
It's extremely complex, and I think we need to remember that no detail is too small. So for example, someone in the chat brought up about Amber Alerts, and they were referencing being alerted to a missing child that was 6 hours away from their location. But I'll tell you something, in the interviews I had with residents in Dunrobin, there were at least a few who commented on how the sound of the Amber Alert is the same as the sound that comes through when the emergency tornado alert came through, and how people, that somehow signified to them, oh, it's another Amber Alert. I mean, of course we need to be taking those seriously, but that influenced people's reception of that alert message, that the sound was the same. And so this offers another consideration for what we can do. Maybe we can make the sound different, and that might signify that this is a weather emergency and not a missing child emergency.
Very good. We had that same issue here in Nova Scotia. Dave, the last comment on this really good dynamic conversation. And
Yeah, just a couple of quick points. Yeah, Fred, hi Fred, is down in Montreal, and the Montreal, Quebec City area, you know, there's not a lot of tornadoes that occur in that particular spot, at least historically. But as you saw from the NTP presentation there, just to the north of that area, there were 41 tornadoes over 2 years. So I think a lot of people in Quebec didn't believe that at first, that where are all these tornadoes coming from? So, you know, that's one of the things with NTP, we're trying to raise awareness that, hey, the tornadoes do occur in your area. It might not be exactly where you are, but you better be prepared for this kind of thing. The other thing is that, you know, in order to really do a better job of warnings with severe weather and especially tornadoes, we really need the nowcasting tools. And, you know, this is like a 0 to 1 or 2 hour kind of tools, mostly based on radar, but also lightning and satellite. We've got lots of data coming in that will help us. But in Canada, we just don't have the nowcasting tools that allow us to do a really good job there. In the States, they've got a couple things like they've done kind of a machine learning approach to it, where they can forecast if a storm is, what the probability is that a storm is going to become severe in the next 30 minutes or produce a tornado in the next 30 minutes based on AI. And this is the kind of thing we need to do, is, you know, make use of all of this data that we've got and try to come up with better nowcasts so that we can really improve the specificity, like the time and the location of these severe weather threats.
thank you, Dave. And I had a call yesterday, funny you say that, with a fella in the States who's got a company that uses AI for disaster response. And I'm asking him to talk at a conference that I'm involved with. So these are wonderful opportunities that are coming up. The science that we use is not going away, it's only getting better. So we have run out of time. We're going to keep the chat questions and comments. We'll ask some of the panelists to respond directly back to some of the questionnaires. We had a nice back and forth on the cost benefit for adaptation, whether it's 1 to 4 or 1 to 6, and that there's some low hanging fruit like hurricane clips, where for a very small amount of money, you can have a very big impact on protecting your property. And so I really want to thank the participants for being very dynamic and talking with each other, and the 4 panelists not only giving great presentations, but also responding to the questions that I directed to them, but also keeping up with the chats themselves. Poor Jennifer, in the middle of a question, I asked her, she was answering a fella on the chat room. So it was really engaging, and I really thank the participants and the 4 speakers for an engaging couple of hours. As I mentioned, the session has been recorded, so everybody will get a link to that. Also, I hope that we'll be able to give you a short survey, access to a short survey, so we can get some ideas on the value of this format and other topics we may actually consider in the future from CMOS. And finally, I'd like to thank Len and Gordon for this idea, the group from CMOS Ottawa, and finally Gordon Griffith, who's not visible to me, but he's navigating the Zoom call and the registration and certainly the navigating all of the enabling for us to be able to offer this today. So once again, I'd like to thank everybody, and we'll close the call on that. Have a great Thanksgiving.